Hi all, this is Padmapriya from Information Technology, SNS College of Technology, and I'm going to discuss the topic about process scheduling and synchronization. And under this concept, I'm going to explain what is deadlock. So, before enter to the topic, we just recall the previous session. In previous session, I am just explained about the process and its resources. Generally, process compete for limited resources. Based on the system model, the resources can be limited. So, process can make a process can compete for access that particular resources. So improper sharing, it leads to issues. Improper sharing means a particular resource can assign to particular process. Uh, we have to assign the resources for each and every process is in a proper sharing. So if it is happened in improper sharing, that leads to issues. So deadlock is a major problem. So the topics we are going to discuss about deadlock is a system model, deadlock characterization, handling deadlocks, deadlock prevention. These are all the topics we are going to discuss. So let's explore the concepts about process and resources. Process request resources. Resources are held by others. System gets stuck. What is the thing we have taken from this is process can request some resources. That particular resources are held by some other process means that process can't execute at that time. So in that manner, the system gets stuck because the execution is stopped until that particular resource is assigned to that particular process. So why deadlock is matters means this is the empathize of the deadlock. Process stop executing, resources remain unused, and system means once the particular resources can't assign for the process, resources remains unused because the requested resource can allocate it to some other process. So that execution can happen, but the requested process can held up for allocating the resources. So the system will stuck. Here, process P1 and process P2. Process P1 is waiting for resource R2, and resource R1 is assigned for process P1. At the same time, resource R2 is assigned for process P2, but P2 is waiting for R1. So, in that manner, the cycle will form, isn't it? How it comes means if process P1 once release the resource R1, then process P2 can execute. The same time, process P2 is released resource R2, then only process P1 is access that resource R2. So in that case, both process can executing by using the particular resources. At the same time, both process can waiting for another resources. So in that case, the cycle will form that is called deadlock. So deadlock processes wait forever. In that case, when cycle can form, the process wait forever. Each holds some resources, and that deadlock prevents. And system model means each and every system can have some kind of capacity. Based on that, we can maintain resources. We can't maintain the resources or infinite. So based on the system model, we can maintain the resources finite. So processes request and releases resources, and deadlock occurs during allocation. Before we have seen the thing, allocation in the case process request for particular resources, and the particular resources are can assigned by some other process. Once the resources are relieved from that particular process, then only that resources can access by our process. This is this is the deadlock allocation. We'll discuss the balance thing on the next topic. Thank you.